Hi there, I'm Johannes Winkelmann, Technology Evangelist with Sensirion. Our company offers sensors for a wide range of markets, including automotive, medical, and mobile. Our main focus is environmental sensors with humidity and temperature, gas and liquid flow, and differential pressure sensors being our primary products. The product I'm demoing today is our humidity and temperature sensor SHTC1, which is targeted at mobile and wearable devices. It's 2x2 by 0.8 mm small and very power efficient, which also makes it well suited for battery-powered devices. Typical uses include context-aware apps, indoor weather stations, and monitoring of environmental conditions for sports and lifestyle products. We joined Atmel's Sensor Hub initiative to make the process of developing prototypes and final products easier and faster, and have built a sensor wingboard to go with the Atmel D20 Xplained Pro Sensor Hub platform. What you can see here is the wingboard, which includes the SHTC1. The cutout around the sensor is to decouple it from potential heat sources, and while it's not strictly necessary here, it's still a good idea to have it. Other than that, the board includes level shifters for the supply voltage and an ID chip. I'll also be using Atmel's OLED1 module to display the current readings for humidity and temperature and the dew point, which is calculated on the fly from these values. With that said, let's move on to the demo. I'll just plug into two extension boards to the Xplained Pro board. As the next step, I'll connect these to the laptop using USB. USB will also be used to power the device. In order to program the device, we use the free Atmel Studio 6. To learn more about Atmel Studio, please check out the introduction video introducing Atmel Studio 6, two architectures, one studio. In Atmel Studio, I've already loaded the demo project, so I can simply choose Start without debugging from the debug menu. This will then compile the project if necessary, download it to the board, and start it up. The demo project does a couple of things. First, it reads the values for temperature and humidity. The sample rate here is 2 Hz and can be adjusted depending on the application. Usually rates around 1 Hz are sufficient for monitoring. However, when using humidity changes as a trigger, it can make sense to sample faster. The code then calculates the dew point based on the current humidity and temperature values. Finally, all these values are displayed on the attached OLED screen, which you can see here. Besides that, the demo application also sends the data to the board serial port, which can be monitored directly in Atmel Studio using the terminal window extension. If you can't see the terminal extension in your Atmel Studio, make sure that it's installed. To make things a bit more interesting, I will now cool down the sensor using this standard cleaning spray. Watch closely what happens to the temperature value. As you can see, there's a pretty immediate and strong drop in temperature caused by the cooling spray. In addition to that, we also implemented a simple breath detection using humidity by measuring an initial baseline value when the board is starting up and checking for a deviation larger than 5%. In case this is detected, we turn on the LED on the main Xplained board. Let's check this out. As you can see, the LED turns up really fast, and therefore is a good input to trigger actions. As mentioned, for such application, it usually makes sense to increase the sample rate to get a faster response. Moving back to Atmel Studio, let's have a quick look at the code to see what's needed to read the sensor. First, there's some generic initialization code, which is needed to initialize the bus. We then call SHTC1 probe to check whether the SHTC1 answers on the bus. If this is successful, we call SHTC1 read HPM sync to trigger a measurement in high precision mode and read back the values. We then format the data for output. This code is called in an infinite loop. For applications that are more time critical, there's also an asynchronous function to start the measurement in background with a second call to collect these results. These functions are SHTC1 read HPM async and SHTC1 read async result, respectively. The full API is documented as part of the sensor driver, which is available from the Atmel gallery. For more information about our sensor solutions and Atmel Xplained Pro integration, please check out our website smart.sensirion.com and let us know if you have any questions. We look forward to seeing our sensors put to a test by you.